All right, there we go. So if you recall, right, we started on Friday. We were looking at, oops, I'm frozen. There we go. We were looking at problems here that first gave us the directions for each function given, determine the slope, the y-intercept, and the x-intercept, right? And so these are like important pieces of information about our linear relationships or our linear functions or our linear equations, right? These are important pieces of information that we want to be able to pull out, okay? Because typically the y-intercept, the x-intercept, the slope all have meaning within the line and stuff like that, okay? So being able to find these three things is pretty important. And so for the y-intercept and the x-intercept, it's a matter of just plugging in 0, or in this case for the graph, we can just see them, right? Y-intercept, x-intercept. And then the slope, okay, the slope, that's just counting, right? Just rise over run, or you can pick 2 points and use the slope formula, your choice there. Here, same thing, except we do what Alex did earlier. Alex, if you guys remember, he was plugging in 0 for the x-coordinate to find the y-intercept. He plugged in 0 for the y-coordinate to find the x-intercept. Okay, that gave us those. And the slope, again, you can use slope formula, or if you put it in Slope-Intercept Form, this is a faster way. The Slope-Intercept Form gives you both the y-intercept and the slope at the same time. Makes kind of nice. Okay. We did the same thing here for number 5. We just had some decimals thrown in, so it wasn't too crazy. Then we did this number 7 here, applications, right? So context. What's happening in the story, right? And using the information to help us, kind of tell more what's going on. So we talked about Billy who rented a moon bounce for the carnival. And the rental fee for the moon bounce was $100 plus $25 for each hour of the rental. So the function C of H, the cost in dollars for a rental of H hours, is given by this. Okay? And so we were supposed to describe what the meanings were. So find the y-intercept. So we put 0 in for our H in this case and got 100. So the starting fee is $100. That's the meaning of it, right? The starting fee, or the time at 0 hours. The cost at 0 hours is $100. Letter B, the slope, 25 over 1. So it's $25 per 1 hour, right? That just was the rental cost. And then here we graph the relationship. Okay, we kind of talked about the domain and the range a little bit. But of course, the domain and the range, it was kind of hard to describe at least what the upper limit was. We can definitely say for sure the domain would start at 0 because it doesn't make sense to have negative time, right? Likewise, we could say the range for sure starts at 100 because that's our y-intercept. Okay? But we can't really say necessarily how far it goes because we're not really sure how long you can rent for and stuff like that, what's reasonable. All right, so we're skipping back to number 9 now. We're going to look at Coach Fry, who's another algebra teacher here in the school. He works with Mr. Goff and Mr. Mills some. Fifth block. You might have friends, Mr. Goff. You might have friends that are in those classes, maybe.
Is it Mr. Goff?
Goff. G. It's like cough, but instead of a C, it's a G. Yeah. So anyway, Mr. Goff, that's right. Coach Fry has discovered he has a termite infestation. Oh no! The exterminator said that he found that a nest had 450 termites, and his gas will kill 75 termites each day. But the function P of T represents the population over T days. All right, so the first thing we're asked to do is to write a function for this situation. So what do you say? Oh, someone who's here. Let's go to Carson. What might be the function we write here? P of T would be equal to what? 450. Oh, good catch there. Why minus? Yeah, we're losing the population there. The population is depleting or going away, so we're killing them off. Yep, perfect. All right, let's go to Simon. Simon, so this is kind of in slope-intercept form, right? What would the y-intercept of this be? What number? Careful, 75 has the t next to it, so that wouldn't be the y-intercept. That's going to be the... Yep, it's 450. Or as a point, right, 0, 450. Okay? So Simon, what do you think this 450 then, what does that represent in this problem? A number of what? Yeah, the number of termites. When, though?
Per day.
Well, per day is 75. He kills 75 each day. Think about what the 0 means. 0 is a number of what? Days. So that means if it's 0 days, that means we're at the start, right? So at the start, there were 450 termites. So the number of termites at the start was 450. Okay? Yeah. All right. Questions on A or B so far? All right, so letter C. Let's go to Reagan. So Reagan, we want to find the X-intercept now. Okay, the X-intercept. Now, this is in slope-intercept form, right? We already identified the Y-intercept. We know this negative 75. That's not going to be the X-intercept. That's going to be the what in this case? Anybody? Negative 75 is going to be the what of the line? The slope. Okay, so we'll get to that here for letter D. We're asked to find the X-intercept, though. Okay, so Reagan, any idea about how to find the X-intercept here? So let me help you with this a little bit, Reagan. Okay, an X-intercept is located on which axis? The y-axis or the x-axis? X-axis, right? Okay, easy question, right? Okay, so any point, Reagan, any point that's on the x-axis, what will we know about that point? What will its y-coordinate be? If you're on the x-axis, what's your guaranteed y-coordinate along here? 0. So we have our function right here. Where can I put that 0 then that I know it's got to... So t is like my x-axis. So it won't go in for t, it's going to go in for the p of t over here. That's like our y, okay? So we'll put 0 in for that. Okay? So the x-intercept here is really like the t value we're solving for. The t that makes our function 0. So far, so good, Reagan?
Yeah.
All right, can you help me solve it from here then? What do we do to get the t by itself?
Wait, what did you say?
How do we solve this for t? What should we do?
Subtract 75 on this side.
Well, so it's a minus 75, so add, and we're going to add 75t to both sides, because there is a t next to it too, so we'll have to keep that with it. So now we have 75t equals 450, and then what? To get the t by itself.
Then divide that, right?
Divide both sides by what?
75.
Yeah, you got it. Okay, so the answer is 6. And since this is a t variable, okay, right? So it's 6 comma 0 would be that case, right? Because we put 0 in for the y value there, and then we found 6 for the t value. So it's 6 comma 0 is the point. So t is 6. What does t represent in this problem again, Reagan? T represents a number of what? It's in the last sentence of the top 2 sentences here. What does t represent? A number of what? Days. So in this case, we have the number 6 is t. So that means it's a how many days?
6 days.
6 days. So, okay, after 6 days, what does this 0 represent? The number of what? Termites. So what is that saying then? After 6 days, what will be true?
There'll be 0 termites.
Yeah, there'll be 0 termites. Exactly right.
But, I mean, termites grow up pretty quickly, so would that really be 0? That only be able to go 450, but...
We assume that they're not going to have any babies or anything like that and grow while they're being killed off, too. And you have a point there. You have points.
What's wrong with that?
But for our purposes, we have to make things a little bit simpler than that because otherwise it gets very complicated very fast, and we won't be able to do it by hand anymore at that point. So,
Is it true story?
what's that?
Is this a true story?
No.
Then it would be.
No, Mr. Fry. I mean, I don't know. You could ask Mr. Coach Fry. I don't know. Mark could ask Coach Fry, see if he really knows. Mark knows Coach Fry.
Ask him.
All right, Mark. There you go. Your job for today after school at practice. Coach Fry.
Practice is over.
Oh, practice is over. Oh, well, you can text him or something like that or email him. Dear Coach Fry, I hope this letter finds you well. Do you have termites in your house? Did you have termites in your house? Okay. Shh. Again, folks, this meaning comes up. All right? So like Carson and Alex, right? In the earlier problems, we didn't have a meaning necessarily for our intercepts because there wasn't like a story or a context. But now that we have like this context of a termite infestation, we can say more than just what the Y-intercept is. It has a meaning behind it. Shh, gentlemen, listen up. Okay, same thing here. The X-intercept has the point 6, 0. 6 is a number of days. 0 is a number of termites. So we can use that in our descriptions here. The last thing we're going to do is talk about the slope. Okay, and so the slope, I think we already said it, but I'm going to have someone say it again here. So Catherine, what is the slope in this function? What What's the slope number here?
75.
Close. What's the sign in front of that 75?
Negative.
Negative 75. Yep. And as a fraction, Catherine, that'd be negative 75 over.
1.
Awesome. Good job. Yep. Negative 75 over 1. Okay, now we need to interpret these numbers. Remember that the y values are on top, the x values are on the bottom. So that negative 75 is a number of what in this case? Negative 75 what? Yep. Mm-hmm. Termites, right? Exactly right. Do you see that there, Catherine? That'd be termites. And then and then what's the 1 for? Every 1 day. Okay? So then as a sentence, what could we write here? You want to take it away, Sky? What would the sentence we could be? Every
1 day, there's 75 less termites in the house.
Perfect. Every 1 day, there are 75 less termites in the house. Okay, you could even more simply say just like 75 termites die per day, per 1 day. 75 termites die per 1 day. Something like that. Is that simple? Okay, there's many ways to write this. All right, go ahead and graph it. Let's go ahead and graph it here. Now, let's see, to graph this, let's see, Sean. Oh, he's in the bathroom. Escaped again. Hannah. To graph this, remember our equation again, 450 minus 75t. So where should we start here? 450, and we'll put a point right there. Oh, by the way, what's the y-axis label again? It's a number of what? Termites. And what's the x-axis label here? Number of days. Yeah, we should have those labeled. I think the last one we did, but this one did not. Okay, so 450, and then we're going to use our slope to change, right? So how much do we go down by each time? 75. Ooh, okay, let's see here.
I just drew a line in the middle of the 400 and then 50.
Okay, because down 75 would be 375, right? And that's like right here, and we're going to go over 1, so right there. Like this?
Yeah.
Okay, yeah. So you guys get that? From 450 minus 75, we're now at 375 after day 1. So 375 is halfway between the 350 and the 400 here. Okay? Now, we can keep doing that too, so we can go down another 75. That'll take us down to 300, and then over 1. There is another point that we already figured out, though. What was the other point that we already figured out? We haven't plotted it yet. What was the other point we figured out? 6, 0. So we could just plot the y-intercept and plot the x-intercept, okay, kind of like Alex had us do for the warm-up, if you remember. He just found the y-intercept and the x-intercept, and then we can just connect those dots, and they should all be on that same line. Okay, something like that. I kind of missed it a little bit. Let's see. It should be like right here. Okay. And then to there. And then, yeah, down there. Okay. So there it is. Okay. So the slope of this line is negative, indicating that the line is increasing, decreasing, or constant? Decreasing, which makes sense because what's happening to the population of termites? It's decreasing, right? They're dying off, and so it should be going down, right? All right. Little termite genocide, okay? So, questions on any of that? If not, let's get back then to number 2, okay? And we'll jump back and do these even ones and finish this off here, okay? All right, so number 2. Let's go ahead and do this one here real quick. Actually, I'm going to have you guys try this one. You guys go ahead. Number 2, come up with the y-intercept, the x-intercept, and the slope here. Okay, 2 of these things should be done like that. Yeah. Okay. Okay, so go ahead, try number 2 on your own here. I'll give you like a minute or 2. Try number 2 on your own. Come up with those answers. X-intercept, y-intercept, slope. So the x-intercept is going to be a point along the x-axis here.
We don't know how long it takes.
Well, it's going to be back here. It's pretty. Yeah, it'll be negative 2. Yeah. But again, Reagan is not possessed. Anymore now. You've exercised her.
Everyone's a proper
Hey, I go to church, okay?
How do I Sir, math, enter. How do I So just 8/3.
Yes, so I did that right. Yes.
The first point was the Y-intercept. Because it's on the Y-axis.
So now we have,
Would that be my slope also?
so you know what our slope is, slope is on.
The slope, remember it's in slope-intercept form, isn't it, Carson? So you should be able to just read one of those numbers there. I'll give you the slope.
Always gonna, so what's your slope?
One of the numbers in your equation. Okay, Hannah?
So y, whenever you have a y-intercept, the x-intercept is 0.
So 0 is your Y coordinate. So you plug 0 in for Y,
The
solve.
y-intercept, x is always going to be 0. And on the x-intercept, y is always going to be 0. So,
I'll give you 30 more seconds here. 30 more seconds.
Okay, so far so good.
because this is our y-intercept.
You did it before, didn't you?
So 0 for the next one.
For the x-intercept, you put 0 in for y and solve for x.
No, you're gonna have to solve. Right? So then let's say, so put, you know what y is, put 0 equals
It has the same y-intercept. What's the y-intercept of y? So it's the left. Does that have the y-intercept with 8? So then they have the same y-intercept. That's your answer. They also have the same y-intercept. I know, you got the questions are a little weird, man. You get it. Okay, let's go over this. Here we go, rapid fire. Here we go, number 1. Or sorry, y-intercept. Caden, what'd you get for the y-intercept? Shh. Caden, go ahead. What'd you get for the y-intercept, Caden?
0,
Beautiful. Okay, let's go to the x-intercept. Dylan.
1. I got 2.67.
2.6. Okay, so please don't round there. Okay, that is
2.5.
Nope. 8 over 3. 8 over 3. 8 over 3. Shh, hang on, because Sky's still. Oh yes, just let me just wait though. I want you to tell me how you did this. How did you figure out 8 over 3, 0? What'd you do? What's that? You did the math. Well done, Dylan. That is an excellent answer and not at all what I was looking for. So, how did you do it? What did you exactly do?
0, I put the 0 for Y.
Okay, just stop right there. That's all you got to say. When you're finding the x-intercept here, the x-intercept, put 0 in for the y. Solve for x. Add 8 to both sides. Yes, you may go. 8 equals 3x. Divide both sides by 3. X equals 8/3. There it is. Okay? If I'm to find the y-intercept, I put 0 in for x and solve for y. Or we can just look at it as a slope-intercept form. Okay, last but not least, let's go to Kendall. Kendall, the slope here is 3 over 1. I like that you put it as a fraction too. Okay, if you put 3, that's fine. It's not wrong. But 3 over 1 is good. It's helpful to help us remember that it's rise over the run. So we have a rise number and a run number. Okay, turn the page. No, you. I did. Okay, here we go. The y-intercept. Okay, mark. We're going to do this one here together. Mark the y-intercept. Remember that its coordinates, where does the 0, because the y-intercept and x-intercept, they both have a 0 in their coordinates here. The 0 for the y-intercept, where does it go? In for the x-coordinate or the y-coordinate?
Can you repeat that? Sorry.
Yes, if we're trying to find the y-intercept, okay, there's going to be a 0 as one of the coordinates. Is the 0 in for the x or is the 0 going for the y?
Oh, it's got to be for the x.
Yes, 0 in for the x. So that means we're going to plug 0 in for x to get the matching y. So y minus 3 equals 2 times 0 minus 5. Okay? Mark 0 minus 5?
0. Fine. 5.
Negative 5 times 2, Mark?
Times 2, negative 10.
Negative 10. Mark, solve the equation. All right, well, Mark,
Never.
eyes up here. All right. What do we do now to solve for y?
Oh, plus 3.
Plus 3, both sides. You got it. Y equals negative 7. Okay, so negative 7 is our y-intercept there. Okay, is this equation in slope-intercept form?
No.
No. We could get it in slope-intercept form. We could distribute that 2. Add the 3 over.
That's what Miss Mulkey told me.
Yeah. Okay, there's that negative 7 that Mark said. Right, there's our y-intercept. It's negative 7. Okay, very good. Let's say now we want to find the x-intercept, though. The x-intercept has a 0 for which coordinate? Anybody? The y-coordinate. Okay? So now to find the x-intercept, you can plug 0 in for the y here and solve, just like we did right here for the x. Or you can plug 0 in for the y here. It doesn't matter. I'm going to plug it in here. Okay? Add 7 to both sides. 7 equals 2x. Divide both sides by 2. X equals 7 over 2. Okay, so 3.5 or 7 halves. Okay, so again, to find those intercepts, the y-intercept, you put 0 in for x. The x-intercept, you put 0 in for y. Okay, and then you just solve your equation. Okay, what's the slope? What's the slope here? It's going to be 2, right? Or as a fraction, 2 over 1. Again, I have it in slope-intercept form right here. Okay, or you can also, well, actually, yeah, you probably want to get in slope-intercept form for this case. I mean, technically, that's the slope right there. This is something called point-slope form, okay, where your slope is right here, and then the point 3,5 is on your line. So instead of being given the y-intercept, you just have the point 3,5, and then the slope is 2, and you can graph it from there, too. Okay, so that was point-slope form. If you look down here at number 6, this is also in point-slope form. What's the slope in number 6? Can you guys just read it and see real quick? Remember I said up here the slope was 2. What's the slope here? 8 over 3. It's the number, again, in front of the parentheses there. Yeah, so the slope here is 8/3. This is point slope form. The point here is negative 5, 9/4. It's like the opposite of the sign. So negative 5, positive 9/4. That's a point. But, of course, we don't really plot that because 9/4 is, yeah. Okay?
Thanks, Russell.
When Dylan comes back, you have to wait. Okay? So now we're going to solve here. I'll put 0 in for the x-intercept, and we'll solve for y. So 8 over 3 times 0 minus 9 over 4. Y plus 5 equals 8 over 3 times negative 9/4. Multiply this out, and you get, that's not too bad, actually. It's negative 6. Okay, subtract the 5 over. Y equals negative 11. Okay? Did I make an error, Ms. Mulcahy?
No, I just have to look at mine. I wasn't following. I got a different answer, but trust me.
Okay, yeah, because I think it's right. I think I got it right there. Yeah. Okay, the x-intercept. Which coordinate is 0 for the x-intercept? The y, yeah, because we're going to solve for the x value. So put 0 in for the y. Okay, we get 5 equals, I have to distribute that 8/3, I guess. Okay, 8/3 times x is 8/3. X, 8/3 times 9/4 is minus 6. Add 6 to both sides. We get 11 equals 8 over 3. And then I'm going to divide both sides by the fraction 8/3. Okay, and I'm trying to hurry through this because I feel like we can do the algebra.
Quick question.
Yeah, quick question.
The first part. So if you use the distributive property,
Yep.
8/3 times x
Uh-huh.
and 8/3 times negative 9 over 4.
Uh-huh.
Uh-huh.
Yep, you get 8/3 x, and then 8/3 times 9/4 is 6.
Don't you have to use the distributive property over on y-intercept?
I didn't because I did 0 minus the 9/4. You could have if you wanted to. You would have done 8/3 times 0.
Different answer, so obviously I did something.
Yeah, it
But
should
if
still
you
work.
did do the y-intercept, I mean, if you did use the distributive property,
Yes.
it would have been 8/3 x minus 72 over 12.
8/3 times 0, 0. Minus 72 over 12
Yes.
there.
Yes.
So it'd be negative 70, this should be negative 72 twelfths.
So you would never have used the distributive property up there.
You didn't have to, but you did. If you used it, okay. It should still be okay. And negative 72 over 12 is negative 6.
Really?
Uh-huh.
Oh, yeah.
Yes. Yes. Okay. Turn the page to number 8. Jeez. Okay. Number 8, we're talking about the value of a washing machine in dollars after t years. It's modeled below by the function v of t. Okay. So, Erica, letter A, can you tell me what the y-intercept is for this particular graph? What is the y-intercept? Or where does the line cross the y-axis? At what point?
In the middle of like 200.
Up in here? Okay, so remember the y-axis is actually not in the middle here. We're only showing you the first quadrant. This is the y-axis, and this is the x-axis. So, where does this line actually cross the y-axis? At what point? It does, right up here. See that? So, yeah, 0, 500. Yep. 0, 500. Now, that x-coordinate of 0, okay, the x-coordinate of 0, Ben,
What?
the x-coordinate of 0, what does that represent in this particular problem? A number of what?
The number of whatever is on the left.
Sorry, the
I
x-axis.
know it. The value. Oh, never mind. It represents the years.
Okay, 0 years, and then what does the 500 represent?
What is the what now?
The 500 represent the y value here.
Oh, that represents the amount of money that the washing machine value have increased because of inflation.
Or sure, just like the worth of it, we'll say. Yeah, the worth, its value, okay? So yes, so at the start, okay, or after 0 years, you can say that. At the start, the washing machine is worth $500.
Oh, I just realized it's going down in value.
Yes, it is. Yeah.
I thought the price was like increasing.
Oh, I see what you're saying. Yeah, no, it's over time and then the value of it. How much you'd sell it for, kind of thing. Okay, very good. Let's go to Ella then. Ella, what's the X intercept here? Or what's the point where the graph crosses the x-axis? 5, 0. Very good. Okay, can you kind of give a description of what that means? So let's do the x-coordinate first. The x-coordinate is 5. What does that 5 represent? A number of years.
After 5 years, the value of the washing machine is 0.
Perfect. Yeah. After 5 years, the value of the washing machine is $0. Okay. Now that doesn't mean the washing machine's like not working anymore, right? It just means if you were trying to sell that washing machine, you would get $0 for it. I'm sorry, I'm off the screen. Okay. It's like a car too, right? Someone might say, "Oh, that car is like worth, like nothing. Like it's like a hunk of junk." But if it can still get you from point A to point B, that car still got some value in it to someone, right? Even though it might not look the prettiest, right? But as long as it can get you where you need to go, well, that's better than nothing. So something to think about, right? All right, the slope, all right, we have to figure that out here too. How can we figure out the slope? Let's go to Tyler, C.
What's up, Chief?
What's the slope here, Tyler? How can we figure that out?
Okay. So you look at like
Let's go up to the graph.
so 35. You're gonna get 4. So you go up 1, 2, right?
Okay, so you're going from this point, you're saying,
Yeah.
to here?
Yeah.
Okay, you said you go up 2, which is really going up by how much?
100.
So we're going up 100, so that's a positive 100 over, so positive 100 on top, because we went up 2 boxes, which is really up going up 100. And then we're going to go, what direction now?
To the left.
Left 2, but that's really like going left how much?
1.
Yeah, if we go from 5 to 4 in 2 boxes, that's going left 1, so negative 1. Okay, or we could say negative 100 over 1. That's another way to say this too. Okay? Tyler, what does that mean then in the context?
Just like -100. Yeah, I think
Negative 100 what in this case?
$100.
Dollars every, sorry, negative $100 every what?
Would it be every 2
Years.
years because it goes down one year? It goes from 500 to
Yeah, I would say years.
Right, but every other block is 1 year. Like, so every 2 blocks is 1 year though. Right? Yep. So yeah, you see that? Yeah, so every year the value decreases by $100.
So will it eventually get to the point where you pay people to use it? Or you'll pay people to take it?
So, that might sound weird, but in some cases, yes. So, for example, if you can imagine, like, to get rid of tires, for example, right? When you go to get new tires, you have to pay the tire people that change your tires. You have to pay them to take your tires from you because tires are so hard to dispose of that the government forces you to pay money. So yes, in some cases, your tires will not only be worthless, you have to pay money for someone to take them away, to handle them. Or if you imagine, your washing machine, if you're going to go get rid of it, you can't just like dump it on the sidewalk. You have to take it to the dump. Well, and the dump charges by how much weight you take into the dump to get rid of it. And so then another way, you have to pay in order to get rid of your washing machine. What's that?
Some dumps don't.
Some don't, you're right. And some, like, every once in a while, they'll take, like, bulk trash or whatever, too. I don't know if a washing machine counts or something like that. But, so in a way, yes, you do kind of end up paying for it.
You just like donated to companies.
It is. What's that?
You just donate to companies if they're reused. Like,
Well, so, I mean, there are places that will, like, try and fix up your washing machines and stuff like that and then sell them to other people or, like, give them away or something like that, too. I mean, that's possible. So that's an option where you could get rid of your washing machine and then you want to pay for it because you're going to help somebody else out. So it's possible. But have I done it? No, not yet. But hopefully one day when it comes to the point, when it's possible, when it's time. Anyway, letter D, last thing. What is V of 3? So we go up to the function here, okay, and we want to find the value of the machine at 3. What is the value of the machine at time 3? $200. Very good. Yeah, here's 3. So V of 3 would be this point on the line. Okay, there it is. So it's $200. Okay, so what does it mean here? After
3 years, the value of the washing machine.
After 3 years, the value of the washing machine is $200. Okay. Now again, you guys might not be so concerned about washing machines, but your car, okay, your car pretty much depreciates in value unless you wait so long that it becomes a classic, and then you could, maybe it'll go up in value a little bit. But most likely, you won't be waiting that long to sell your car. But anyway, so there's that. Okay, we're going to do one more here, or at least with the amount of time that we have left, we'll do as much as we can. Okay, I'm going to at least get the function written down here. Okay. We'll at least get the function written down. Okay. Number 10, Mr. Widmeyer, hey, that's me, decided to start saving money for a vacation. I do like to go on vacation. He decided to make extra money by working children's birthday parties as a singing, juggling clown. Well, it's not a birthday, so sorry. It's only for birthdays. What's that? I can't juggle, actually. I would like to learn how to one day, but not right now. Anyway, he currently has $100 saved and makes $50 for every birthday party he works. Let the function M of B represent Mr. Widmeyer's savings after working B parties. So M of B. All right, so let's go to write this function here. So, someone who's here. Let's go to Shepard. Shepard, what would be the function we could write here then? I currently have $100 and I make $50 for every birthday party I work. So what could I write for the function there? Well, so I start with 100, so 100, and I'm going to make more money by going to the birthday parties. Plus 50, and then B for the number of birthday parties that I work. That's it. That's the function. Okay, Dylan, is that what you were going to say?
Yep.
All right. So, Dylan, what's the y-intercept of this function? 100. Okay. We'll come up with the x-intercept here in a second. Let's go to Kendall. What is the slope? Let's just skip to the slope here, letter D. What's the slope here, Kendall, for this function? So 100 was the y-intercept. What's the number next to the x? Or what? In this case, it's the b. So he has 50 in this case. The number next to your variable, that's going to be your slope when it's written in function notation, or the linear. So it's 50 over 1 then, yeah. Okay, so here's what I'm going to have you guys do then, okay? What we're going to do is I'm going to have you guys finish up b. So that means you still need to give the representation. What does it mean? You have to find the x-intercept, and then what does it represent, okay? Letter D, you still have to do what does this represent, and then letter E, you need to graph it, okay? So I'm going to have you finish up the rest of this. You have a few more minutes, and then whatever you don't finish will be homework tonight, okay? Whatever you don't finish will be homework tonight. Sorry, we ran out of time there. Done.